Great seeing you here. My name is Luc de Kuster, founder of the Kuster Academy, and in this video I want to talk to you about the activity on the node methods, and I want to describe the different type of dependencies that you can find here. So let's have a look at the WBS, the activities and the dependencies. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look. So what happens once we finish the WBS? The end of the WBS, according to PMI terminology, is when we reach the level of work packages. Those are groups of activities which can be estimated independently, which can be executed independently, which can be done by one team. Now, in certain cases, in many cases, when we have larger projects, these work packages are basically also mini projects, and we have to decompose them further up till the moment we reach the level of activities or tasks. Now, the WBS is a very important and useful tool, and it provides us with a logical overview of the project. It does not provide a time-wise link between the activities. It doesn't tell us which activity has to be completed before we can go to the next one. So this is something which we don't get from the WBS, but we find all the activities. And now we know what they are, how we have to estimate them, what people we need to do them, and we can order them in a way that they can be executed properly. So we have to identify now what are the dependencies, what are the relationships between these activities. And for every activity, we have to identify what activity has to be completed before we can start with that specific activity. Let's have a look at the dependencies itself. Now, we have to find out what activities have to be completed before a follow-up activity can start. And here I have a very simple network composed of 5 activities, A, B, C, and D, and E. We see A, B, C, D, E are in fact follow-up activities. B, the relationship indicated here, it means that B can only start when A is finished. C can only start when A is finished, but D can only start when B and C, when both of them are finished. However, E can finish when C is finished. So these are the typical elements. You can say, first of all, you have to dig a hole before you can put a tree in there and close the hole. So there are things like this. A could be digging the hole. B could be planting the tree. C would be putting water on the tree. We can only do that, or we can put it in the hole. It's not necessarily that the tree is in there, but we can do it in parallel. And finally, we can only close the hole when everything has been finished. Task E is something else that we have to do. We have to refill, for example, the water can. We can only do that when we put the water in there. Now let's have a look at the starting dependencies and the project start. Now we have to first look at all those activities, and we have to find the activities which have no predecessors. In this case, activity A. We can have more activities that have no predecessor. It means we can start by executing these activities once the project starts. We have no predecessors. On the other hand, we have ending dependencies and the project ends. Now, here we have the activities D and E. D and E have no successors. It means after completing the activities D and E, there is no more work to be completed, and it means that the project is completed. So now we have the starting and the ending activities, but we still have intermediate dependencies. Now, when we look at the dependencies or the activities B and C, we see that they have predecessors and successors. So these are the intermediate activities that are completed once the predecessors have been completed, in this case A, and they will give the start, once completed, to the successor activities, in this case D and E. So we can basically find 3 types of activities. We have the start activities, activities without any predecessor. These are the activities at the beginning of the project. We have the activities which have no successors. These are the activities at the end of the project. And then we have all those intermediate activities that have to be completed in order to complete the project. Now, when we look at the activity on node method, we have in fact different different precedence relationships that we can use. Typically, the most used one is the finish to start type, is the easiest one. An activity finishes and the next activity will start once the predecessor is finished. We find it in a lot of applications, but the method also provides integrated additional relationships that we can use, and it may help us to have a more efficient schedule. These are easy to define in the activity on node methods. They're more difficult to define on the activity on arrow. So this is also one of the advantages of the activity on node methods. Then we have start to start. So when A starts, B can also start. Then we have start to finish. So A starts and then B can finish. And we have finish to finish. So A and B can only finish when both are finished. So these are the 4 dependencies. Sometimes we also talk about percentage complete, which can be used. But for PMI and most of the software, you only find these types of activities. Now, there is also another additional element that we can have. We can consider leads and lags. Now, what do we want to do? We want to say there is a waiting time between the end of an activity and the start of the next activity. Let's consider the curing of concrete. It typically takes about 28 days for the concrete to get its full strength between pouring the concrete, from the moment we pour the concrete. So the activity pouring the concrete is completed. Now we just have to wait the 28 days, and that's a lag. We have to wait longer. Now we can also say, okay, we can start earlier. So normally we write a program, and we once the program is finished, we can in fact write the manual or the documentation. This could start earlier, so we can give a lead, and we could start earlier with the writing of the documentation. So let's have a look. When we have a typical finish to start activity from A to B, we see that A and B are linked in the Gantt, in the, let's say, when we look at the time of the activity. So activity A finishes and then B starts. Now, when we have a lag, it means we will wait a certain time after A is finished before we start with activity B. On the other hand, we will have a lead time. B normally starts after A, but we give it a lead, so it will start earlier. And we find the lead is the finish to start minus the time. And for the lag, we have the finish to start plus the time. So these are the 2 different elements that we can include. And it gives us the possibility to say, okay, the activity is finished, which is important in planning. And during the lag time, for example, we're just waiting. We're not doing anything. We're not spending any money. And we will be working on other activities. For the lead time, it will give us the possibility to start earlier and to shorten the project schedule and the project duration. So that was the overview of the different dependencies when we have the activity on the node method or the precedence diagramming method, and also the definition of leads and lags. So that was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next video. Bye bye.